Hi everyone, welcome back to Arista Community Central. My name is Francisco Sencion, and today we'll look at how to use Arista Event Manager to create event-driven traffic captures on your switch. If you ever chase those random, hard-to-catch issues, then this is for you. We'll let the switch do the heavy lifting for you so you don't have to sit around waiting. Here's what we'll cover in this video. We're going to start with a quick introduction to the Arista Event Manager, then a real case study troubleshooting sporadic CPU traffic drafts. Finally, we'll share some resources to help you go deeper. Think of Event Manager as automation on an airplane autopilot. You set a condition like a config change, a counter increase, or an interface flap and tie it to an action. In other words, if X happens, do Y. Some of the trigger types we could use include on boot, which triggers after reload. On config, react to config changes. On counters, to watch changes on a counter like we'll do today. On interface, detect interface status changes like up or down or IP addressing changes on that particular interface. On login, triggers when a log message is detected. And on static config, which triggers when there's a change to the static configuration. Actions could be as simple as logging a message or as powerful as executing a script, running a packet capture, or pushing some configurations to your device. In our case, we'll create two event handlers. The first one is going to be monitoring the counter drops, and when drops exceeds a threshold, we are going to configure a packet capture. And the second one is going to remove the packet capture configuration once the capture completes. Event handlers have a few extra settings which makes them very flexible. Delay defines how long to wait after the condition has been met before executing the action. The default is 20 seconds. Asynchronous run multiple actions in parallel. By default, only one action runs at a time. Timeout defines the action duration. If an action is not completed before this time expires, the execution will be stopped. By default, the timeout is 10 seconds. Trigger on counter disable is going to allow us to configure our event handler in a way that it doesn't trigger immediately after being configured. Poll interval defines how often the condition will be evaluated. The default is 30 seconds. Here we have a very simple event handler that's going to trigger on boot, and the action is to log a message to notify the operator that the switch was reloaded. Now let's talk about the problem that we're trying to troubleshoot. Our switch is seeing some random drafts in a CPU queue called the control plane system layer 3 time to leave 1. The drafts are sporadic, no clear pattern, so catching them manually will be very challenging if not impossible. But why are these drafts happening? The drafts are not the main issue here. Think of them as just a symptom. There are just too many packets with IPTTL1 arriving on your switch, and by default, we trap those packets to the CPU. The reason we trap into the CPU is because the switch will need to generate an ICMP unreachable time to leave exceeded. Now, as you may know, Arista switches have a built-in control plane policer. This control plane policer, for example, for the queue in question here, has a shape configured by default. If the rate of these packets with TTL1 exceeds the default 2500 kilobits per second, we are going to automatically shade the traffic and the excess traffic will be dropped by the policer. Now, please keep in mind that the output of the show counter queues summary varies between platforms. Now, our goal is to identify what the traffic is that's causing these drops. Once we have identified the originator of the traffic, we can trace the issue back to the source. Let's talk a little bit more about the plan. We'll use the trigger on counters to help us run the show CPU counter queue command, filter the output using regular Linux commands such as grep and awk. Once we have the drag counter value at hand, we are going to track its increments using the .delta modifier. So let's say, for example, that on poll number 1, the value of the drop counter is 0. Then on the next poll, the drop counter is 5,500. What we are going to do with these two values is compute the differences between them. In other words, we're going to say if 5,500 minus 0 is greater than 5,000, then we'll trigger the action. Let's have a closer look at our two event handlers. The first event handler is going to be the one with the logic to monitor the drop counter, and when the drop exceeds a certain threshold, we are going to trigger the action to start the packet capture. But let's go ahead and break down this event handler. We're going to start at the bottom where we have the trigger on counters. The first thing that we have is poll interval set to 2 seconds. What that means is that we are going to be evaluating this condition every 2 seconds. Now, in the condition, we are going to be executing an EOS CLI command. This command will be executed from within bash. This is the reason why we have the fast CLI, and then we have -p, which is to define the privilege mode. In this case, is privilege 15, and then -c, which is going to take the actual EOS CLI command as an argument. The command that we're passing here is the show CPU counters queue summary type non-zero. Now we are going to be filtering the output of this command using egrep. The idea here is that we only care about the row that starts with the CPU queue name. The result of this filter we are then going to pass to awk with a simple print $4. 4 here just represents the column of the output that we just filtered. So the drop value is going to be pretty much the 4th column. Now, if you notice, we have delay 0. This is because we want the capture to be configured as soon as the condition is met. If you notice under the action bash, we have multiple commands. First one is going to be logging a message indicating the CPU drops are occurring. And the second command is going to be to configure the tcpdump packet capture. The packets that are going to be captured will be written in Flash in a file named ttl1_capture, and we are only going to capture 1,000 IP packets. Now, once we have the packet capture configured, we are going to log another message indicating that the packet capture has started. Now let's shift focus to our second event handler. The condition here is looking for the last log message generated by the previous event handler. Once this condition has been met, we are going to wait 60 seconds so we can give tcpdump enough time to do the packet capture. Now, after 60 seconds, we are going to execute the action, which is to remove the tcpdump configuration that the previous event handler configured. Let's configure our event handlers and see if we can identify the traffic causing the IPTTL1 CPU drops. ER1 is the device that's experiencing the CPU drops. We're going to show you first that the issue is indeed happening at very random times. So at some point here, we're going to see those drops showing up, as you can see from here. Now we can see we have some drops happening at a very sporadic interval. So now we're going to go ahead and configure our event handlers to help us capture some of the traffic hitting the CPU during the time of the issue, so we have a better understanding of where the traffic is coming from. We're going to move to the configuration mode so we can go ahead and configure our first event handler to monitor for those drops and start the packet capture. Let's go ahead and configure our second event handler, which is the one that's going to be removing the tcpdump config once the capture completes. We're going to paste that in, and then we can just go hit end. We can also check the state of those two event handlers by running the show event handler and then the name of the event handler. We can see from here that this event hasn't been triggered yet because the issue is not present at the moment. We can take a look at our other event handler, and we can see it is properly configured, but it has never been triggered because the first event handler has not been triggered either. So now let's go ahead and monitor the drops on a CPU queue with the watch difference command. This is going to help us monitor the counter increments in real time to at least notice when the drops are happening. Okay, so we can see from here that we are seeing some CPU drops on the TTL1 queue. Let's take a look and see if our tcpdump was configured and if it is running. We're going to run show tcpdump. And here we can see indeed our tcpdump capture is currently running. And here we can see the configuration that was configured by our event handler. So this is good news. Now let's do a watch diff on the show tcpdump command to see if at some point this tcpdump capture is going to be removed. There you go. tcpdump config has been totally removed by the second event handler. We are going to analyze the packet capture file right from the Arista switch. So we are going to drop in bash. We're going to run tcpdump. We're going to put 2 N's here for no name resolution. And then we're going to say R, which is going to allow us to pass a file. The file, it's located in Flash, which should be MNT Flash. And the file name should be TTL1 underscore capture 0. Let's execute this command and see what packets we were able to capture here. All right, so I can see quite a lot of packets and most of them are following the same pattern. However, here we cannot see the TTL. We need to use the verbosity capability of tcpdump to be able to see the TTL of these packets. I'm going to add V for verbosity and let's rerun this command now. All right, so here we can see that indeed, this is the traffic that's arriving on our switch with TTL1. It looks like most, if not all, the traffic is coming from this source towards this destination. Whether or not this is legitimate traffic is up to the operator to confirm, but at least we were able to isolate the issue using event handlers. Here we have a few links that we think you're going to find very useful. We're going to leave a link for these toys in the video description. That way you can continue to go deeper on this feature. That's pretty much it for this video. We hope you found it informative and we thank you for watching.